We're looking now at the second part of this question, where we've got our same scenario. We've got our aquifer, that's made up of a gravel bed, and in there's this artesian water pressure. So there's a pressure in this gravel bed, and that pressure there is causing an upward flow of water, okay, at a certain rate. Now, whilst the velocities might change as it goes through different permeabilities, the flow rate will be the same flow going all the way up through. We've also told something about the groundwater. The groundwater level is up here. Groundwater level. And our task is to find out what is this artesian pressure. Artesian pressure in the gravel. So this little challenge is really about trying to deduce how do we work out the artesian pressure, and what do we know, what don't we know. There will inevitably be an excess head. The pressure in the water in this gravel bed is such that it causes a flow upwards. If we were to drill a borehole down through the strata, the water would come above the ground surface. So this water flowing upwards is got to sort of combat the sort of downward pressure of the groundwater flow. So you can say that there'll be an excess head across this whole strata, this whole 6 meters of soil. There'll be a sort of excess head across that 6 meters of soil, and that excess head would be equal to whatever the artesian pressure is. I think we should probably just call it AP, because it's a long word to write. It's our sort of artesian pressure less the sort of groundwater pressure. And that results in this flow. We call it Q. And so if we knew we know what groundwater pressure is, particularly as we go down, we can that's a known for us. Okay. You could at any point sort of calculate what the pore pressure is due to groundwater. But this flow rate Q is something that we need to find, and this comes from a knowledge of Darcy's law, where he talks about the flow is the area multiplied by K multiplied by the hydraulic gradient. So the area in this case is whatever area of channel we're considering. So perhaps we could say areas is we could just assume a 1 meter squared, or most of this, we could do 1 meter squared. Put this whole problem in meters. 1 meter squared. And K, well, if we were looking at the whole strata, we would be using KZ. So K is the permeability. Okay. And I is our hydraulic gradient. So for the whole strata, K, we've got KZ from the previous question. And the hydraulic gradient is whatever is the head difference. Let's just put that in here. KZ for the flow across the whole thing will be KZ. And the hydraulic gradient would be the sort of excess pressure. All divided by the flow length, or the flow path length, which is that 6 meters. Now we don't know what the excess pressure is. We know what the error is. That's fine. We know what that is. We don't know what the excess pressure is. Obviously, we know what 6 meters is. 6 meters. So there's quite a few unknowns. What we do know, though, or what we're told in the problem, is that Q Well, we are given a bit more information specifically about soil A. And we're told that the head difference across this, and if we were to imagine a sort of piezometer at the top and at the bottom, we're told that the head across this one is 150 millimeters across that strata, which was 1 meter thick. So we can from that knowledge there, we can work out what Q is, because the flow across that strata would be A times K of this soil multiplied by the hydraulic gradient across A, if you like. Where A is our, let's keep to the units again, let's say that's 1 square meter. Ka, okay, we found that from before, which was 3 times 10 to the minus 1 millimeters per second. We ought to get that in meters per second in a minute. And our hydraulic gradient here is the 150 millimeters, which is the head, and the divided by the flow path length, which was 1,000 millimeters. So the millimeters cancel out on there. So there you go. And we can get that. So that will enable us to find what Q is. Once we've got Q, that is the same Q that is going through the whole strata, and we can use that then to work out our excess head for the whole problem. So your task now is to work out what is Q, and when you've got Q, you'll be able to then use that same value of Q in this earlier challenge to find out what is the excess pressure. Okay, if you know what this excess pressure is, and you know what your groundwater pressure is, you'll be able to work out what your artesian pressure is. Okay, so good success.